What is up, everyone? In this video, I'm going to make a TCP server implementation with Hollywood actors, with the actor model paradigm. Because Hollywood is basically, for the people that don't know, Hollywood is an actor engine, an actor model framework for Golang that I create myself, based out of frustration from other actor frameworks, because I'm using that heavily in production. Especially in highly concurrent distributed environments, the actor model is king, in my opinion. So I created one myself, and I'm basically almost at the pre-release. And I thought, why not make an... in the example folder here, as you can see, I have a couple of examples. And yeah, I want to make the TCP echo server, basically, right? So without any further ado, before we start, if you're not subscribed yet to the channel, please consider subscribing, give me a thumbs up, and leave some questions in the comments. And of course, jump into my Discord community if you want to learn more about all that shenanigans. And of course, check out the Patreon page. I have a Patreon page where I'm doing the most advanced stuff. All right, so examples. I already checked out a new branch, example TCP, and I'm spitting on my own microphone and my screen, but it's fine. So I'm going to make a new folder. I'm going to call this TCP echo. TCP echo, that's fine. Is it fine? This again, the naming paradigm. TCP echo server. Oh, man, this is actually annoying. Echo server, something like that, right? To be honest, TCP server, fuck it. All right, cool. Make a new file, yes, it's gonna be a main.go, and we are ready to rock. Right, so what we're gonna do is, we're gonna make package main, of course. If I can type, func main. Font is huge, as usual, right? All right, let me do the mic and get me in a comfortable position. So the first thing we're gonna do is make a new type. I'm going to call this a server, and that's going to be a struct. We're going to have a listen adder, which is going to be a string. That's fine. Then we're going to say func new server with the listen adder as a param string, and we're going to return an actor.producer, just like that. And an actor producer is basically something that can produce an actor. It's basically a function, so we're going to return a func that can return an actor receiver, something that can receive messages, and in this case it's going to be a pointer to our server, and the listen adder is going to be the listen adder here, right? We're going to save that. Of course, we're going to have some problems because we need to implement the receive method. So we're going to say func s server receive. It's going to be a c actor context. Yes. And we're going to say switch message is going to be the C message, the contact, the current message, the type. We're going to switch on the type of that, right? We're going to say case an actor started, right? So what Hollywood is going to do, I'm going to send you messages. It's going to send you messages when your actor is spawned, when it started, when it stopped, when it's initialized, and all that stuff. So we can act upon that. That's why it's an actor, so you can act, right? Stopped is what we need, and actually, to be honest, maybe also an initialized, right? An initialized. So what we're gonna do is we need ln, which is gonna be a net listener in here. So in initialized, first of all, what I'm gonna do is this for the compiler. When we are initialized, I'm going to do this. Ln error is going to be a net listen. And we're going to listen to TCP, and it's going to be the S listen adder. If the error is not nil, so a couple things we can do, because in an actor model, in an actor environment, there is a supervisor, and the supervisor will basically restart your actor each time it basically borks when it crashes, right? So if you do a panic here, it's actually perfectly fine, right? And the reason is because it's a fault tolerant. It's basically going to restart. Depends on, I think the default restart is 3, but you can make it 10, you can make it unlimited, you can do what you want. So it's basically going to restart each time there is a panic, right? So we're going to panic this error, it's all fine. It's going to try to reboot, and after a couple of restarts, it's going to completely shut down everything, right? So once we have the listener, we're going to say sln is going to be ln, and that's fine, right? So when we are started, you could say log, for example, info w server started, and this log is coming from Hollywood is logging library, right? So we're going to say the adder is going to be as listen adder, right? Boom, that's fine. Of course, this is a map, just like that. So what we already could do is we can make a new engine. We're going to say actor new engine, and then we're going to say e-spawn. We're going to spawn a new process, and that's going to be a new server with a listen adder. For example, I'm going to put it at 6,000. And then we're going to give it a name, and we could give it server. Just like that. Right? And then we're going to say make me a chan struct, and that's fine. So we can block. So each time we're going to say go run examples TCP server main.go. It's basically going to start up our server. It's going to create a listener, and it's just waiting for shenanigans, right? Okay, so what we need is we need an accept loop. So we're going to say s server accept loop. We're going to give it a context actor context. And we're going to say for con r is sln except if r is not nil. We're going to say we're going to say log error w accept error, and then we're going to say log m, and the error is going to be the error we got, and we're going to break here, we're going to break the loop, and it's all fine. So then we have a connection here. A couple things we can do. So normally you would handle, in a normal Golang environment, you would basically handle your connection in a Go routine. That's fine, but can also give you some problems because you're going to need mutexes in your handlers and everything, and that's why you actually using an actor model, so you can get rid of all these mutexes, right? And if you really want to see something fancy, by the way, look at this GG queue. It's a queue I made. It's a lock-free message queue. It's the fastest one probably in Golang written, and it's actually used, right? So it's a lock-free queue. It has cache line paddings and all that stuff. Check it out if you want, right? It's basically me. I made this with some influences from other projects, LMAX and all that stuff. So it's basically not invented by me, but it's implemented by me, right? It's a concurrent save queue, right? So basically you have this connection. So what we're going to do, we're going to make it something new. We're going to make a new struct. It's going to be a session, right? And a session is what I call each time somebody connects to our server, I call that a session, right? It's a session. And that session will have a con. And that's going to be a net con. That's fine. It's going to be a net con. We're going to say func new session, which will take a con net con. And that will return an actor producer once again. And we're going to say return func actor, no receiver, not the other thingy. We're going to return a session with, I'm trying to be fast and that's not good, con, and call it a name. Then we're going to actually say, we're going to copy this receive loop real quick from this guy here. So we don't need to type that much. We're going to say session is fine as session initialized, just like that, right? So each time our session is initialized, we're gonna say we could say something like this as log info maybe, new connection, log m adder con s con remote adder, something like that. So what we're gonna do each time here, we have a new connection accepted. We're going to spawn a child, right? We're going to spawn a new process as a child of the server. So we're going to say context spawn child. We're going to say new session with a connection here. And we're going to give this a name of, this is going to be the session. And then we're going to say actor with tags. So you can give your process a name, but also tags. I mean, the tag of this specific, because we're going to spawn a lot of sessions, right? We're going to spawn maybe 1 million of sessions, 1 million of connections, so 1 million of sessions. So, but we want to diversify the name of the session, and we're going to diversify it by the con remote address dot string, right? Boom. That's what we're going to do. So we can already test this if we really want. So we could do, we're going to run this here. Then we're going to open up a new terminal, and we're going to telnet here to localhost 6000. Boom. Right, and you could see here, wait, something is wrong. Something is wrong here. Except, of course, we don't do the except loop. So our server here receive, when we are started, we're going to say go as except loop with the context. It's fine. So let's test it once again here. Boom. Then we're going to connect with telnet here. Bam. And then we're going to see here, there is a new connection, right? And we can see that there is a new process started here, and a process, this is a server, and this is basically the local server, the session child, and it's going to be this connection, right? If you have a new one, so we could do a telnet localhost 6000 once again, then we're going to see here that there is another process spawned, right? We have 506 and 508, right? And it's all being handled by the actor engine. Fine. Cool. The next thing we're going to do is we're going to keep track of a list of connections, right, in our server. So we could say sessions. And sessions is going to be a map of process IDs, actor pits, right? It's a process ID. Each process has an ID. And it's going to be a netcon, right? So let's do sessions. Going to be make map pointer to actor pit. Net con. What's going on here? Just like that. And then you could say something like, this is the pit. Each time we spawn, we're going to get a pit back. And then you could say as sessions, for example, pit is going to be con. But that's bad. That's really bad. Why? Because we are in a Go routine. So this map is not safe. And we need a lock. But locks are bad. A mutex is actually a bottleneck. It's not a sync.mutex, it's a sync.bottleneck, right? So what we're going to do is basically we're going to make a new type here. We're going to make a type, and we're going to say a con-add type. Connection add is going to be a struct, and that's going to hold a pit, which is going to be an actor pit here, and it's going to hold a connection, which is a netcon, right? So what we're going to do is we're going to say context send, and we're going to send to ourselves, right? We're going to send not to another process, we're going to send to the server is going to send it to itself. So we're going to say as pit, which is the pit of the current context of the server, and then we're going to send a con-add, and we're going to say that the pit is going to be the pit, and the connection is going to be the connection. Boom. So what's going to happen is each time here in our server, we can make another message here. We're going to say if it's a con-add, then we're going to say, then we can safely add it to our map, right? Because an actor is going to process all these messages one by one. So you are not going to have any concurrency problems, any race conditions if you do it like that. And that's the power of the actor model. So we're going to say as sessions, MSG, this can be gone. MSG pit is going to be MSG con, right? Perfectly fine. And we can do a log trace here, log trace W, added new connection to my map or something like that. And then we're going to say an empty, actually we could do a log M, an adder maybe, and then we're going to say MSG com remote, not read, remote adder. Boom. Look at this. Beautiful. So that's fine. We're going to spawn. We're going to send ourselves a message. We're going to add this connection. That's fine. Okay, cool. The next thing we're going to do is we're going to make an echo server. That basically means if we send a message, we also need to read and reply. So in our session here, what we're going to do is we're going to make an session read loop. Yes, a read loop. We're going to say actor context, why not? So we're going to say for, we're going to make a buffer here. Buff is going to be make me a slice of bytes. Let's make this one, this beautiful. And by the way, why are people always using, for example, 1024 or 248 or maybe 128 or something? Because these are numbers that computers easily can understand. It sounds weird because a number is a number, but these numbers, these power of 2 numbers, for some reason computers are super easy or good with that. They are good with it. It's like me and women, right? It is what it is. Give me women, it's all fine. It's the same with the computer. Give them these numbers and they're happy, right? So 1024 is fine. We're going to make this buff. We're going to say that the n number of bytes read error is con read into this buffer. If r is not nil, we're going to say break, and we're also going to say log error w con read error log m adder, no, not adder, r, by the way, r, boom, just like that. Con read is bad, so what we're going to say is scon read, and we have n. We're going to say that the message is going to be n, is going to be buff n, right? What is this? Is basically we have a buffer with this bytes, but we're going to actually, instead of returning all the bytes, we're only going to return the bytes that we have read from that buffer, and then keep overwriting that buffer and all that stuff. Of course, if you have big messages, it's going to be a problem, but that's not for this episode. All right, so that's the message. The next thing we're gonna do is, instead of we could reply here, right? What we could do is we could say, very simple. We could say, if we want to have an echo server, we could do scon write this message, right? And it's all fine. There is a problem because let's say we have a handler. Let's say we have some kind of a handler in our actor that will handle an interface or something that will handle that message, right? The problem is, if we're gonna handle it here, this is prone to race conditions once again, right? Because we are in a, yeah, it is what it is. So what we're gonna do instead, we do it again. We're gonna send to ourselves instead of the server. We're gonna send, the session is gonna send to itself, and we're gonna send basically just a message, right? That's the only thing we're gonna do. So then we're gonna say here, instead of actor stopped, we're gonna say case byte, right? If we just receive some bytes, what we're gonna do here is we're gonna do scon write this message. If VS Code can please do normal. Yes. All right. That's what we're gonna do. Instead of doing it here, we're just gonna say, hey, we're gonna send it to ourselves and handle this synchronous way. Of course, everything is going to be concurrent and distributed, but it's the way you're gonna handle these messages are much more, we're gonna say it's gonna be super secure and fast. Yes, so that's fine. Do we need something more? I don't think so. The read loop, of course, when are we going to spawn at? Maybe we could do it already and initialized or at started. It actually doesn't really matter. We're going to say go as a read loop. As read loop, by the way. Boom. Bam. With the context in it. Boom. Cool. Why do we need the context? Because with the context we can send. What you also could do is basically you could... when the session gets started, you could basically place the context inside of your struct, right? You could say CTX or something with a context here, but hey, if you can pass in a function, why not? It's a pointer, so it's all good. Yeah, I think we can already test this, right? So we're gonna clear the screen. We're gonna run our server here. We're gonna start a telnet client, telnet localhost 6000, right? Boom. And if I say hello, boom, you see, I get the reply, right? GG, boom, reply, AA reply. So it's an echo server. Easy peasy. It's all been taken care of. And you can actually spawn multiple of these clients and they will just respawn, and this guy will also do its thing, right? And you can see all the possibilities because you can easily make a chat and everything. Everybody's connected and the server will broadcast it to every connection it has and all that stuff. So all in a very simple, safe way. With actors, it's a complete different paradigm, but it's for, like I said, for highly concurrent, large-scale distributed systems, game engines, game servers, and all that stuff. trading shenanigans, real-time, soft real-time, that needs to be very fast. Actor is the way to go. A lot of people don't know this because you're still stuck in the basically JSON API request response shenanigans, and that's fine for basic stuff. But if you really want to play with the big boys, actors are very well used, right? Think about Erlang, Elixir. There's a lot of stuff going on in C, in .NET stuff, in Java. A lot of people using that stuff. Okay, cool. So I think, of course, we can make this a little bit better by, for example, what's going to happen if something, if we need to stop the server gracefully and everything, if a connection needs to be removed from its map. That's actually very simple. We can actually do that. For example, our exec loop is here. What we could do here, for example, here, right? So let's make a con remove, and then we're gonna call this a day. So we're gonna say con. Very important, actually, what I'm gonna do. Con rem is gonna be a struct, and we're gonna give it a pit. Actually, that's the only thing we need. Actor pit, just like that. So in our session, so each time we have this problem here, right? We're gonna break here. So each time we actually break here, when the loop is done, we're gonna say C send, and we're gonna send to the server. How can we get the server? Well, it's very simple because we are in our session. It's a child, so we can do C parent. Look at this, man. C parent, and we're gonna send a con rem, and we're gonna say the pit is going to be our pit. What is our pit? C pit. Boom. Right, we're gonna send this. So each time the server gets a con add, so if it's gonna be a con rem, if it's a con rem, we're gonna basically do delete s sessions msg pit. Boom. Just like that. We're gonna copy this line. We're gonna say removed connection from my map. Of course, we don't know what it is. Actually, we do. We could say pit msg pit. Actually, boom, pit of the session, and we could do the same thing here. Add adder pit msg pit. Boom. All right, that's it. Yeah, that's basically the beginning of this. Well, it's almost done, to be honest. A couple tweaks here and there can be done, but you can see that's already working. Hey, go out, use Hollywood, use the actor model in your systems. You're going to have a very good time. There are a lot of examples, and I'm also going to stream later on how to, I'm going to rebuild the poker engine that I'm already building because we have a lot of problems there, and I think the actor model paradigm will help us to make it robust. Right. If you like the videos I am providing to you, consider subscribe and give me a thumbs up. Leave some questions in the comment. And of course, jump into my Discord community, check out my Patreon, and I'm looking forward to see you in the next video. Bye-bye.